This is Dave Zweig from Zarbeco, and in our series of applications for document examiners, we're going to be talking about inspection of pen strokes using the MiScope handheld digital microscope. In particular, we're going to be discussing some techniques that can be used with the MiScope in the examination of ink and pen strokes. And these techniques are, of course, magnification. So using variable magnification to look both at the larger structures and to zoom in and look at the detailed sections of the ink. A variable wavelength, since we can build different light sources into the MiScope itself, we can actually image these inks in different wavelengths. We'll look at techniques in lighting direction, especially using both backlight to look at the ink in relation to paper fibers, and also side lighting for looking at the structure of the ink on the paper, particularly whether it sits on the fibers or whether it penetrates. And finally, we'll discuss a little bit about IR luminescence, or a technique used to actually induce a glow or a fluorescence in the ink chemistry, which can be detected using filters. And we'll demonstrate the MiScope filter wheel, which is an accessory. We're using our latest MiScope MP3, and this is configured with white light, ultraviolet light, and multiple wavelengths of infrared light. The MiScope MP3 is also one of the models that we can modify for what we call EF, or extended field, which allows us to get a field of view in the range of 2 to 3.5 inches. So here for documents, we can actually see a full signature, or we can actually then take our MiScope and remove it, in this case, from one of our stand options that we have, and place it right down on the sample. So some of the questions that we're going to try to answer with the MiScope are questions like, what can I learn about the handwriting? What can I learn about the writing instrument or about the ink that was used to write this document? Are these samples written using the same ink? And other more specialized situations, like if we have an obliteration or a covered area, is it possible for us to see through that and look at the writing underneath? So what we're going to start with is we're going to start with our MiScope MP3, and we're going to look at the range of magnifications that we can cover. So as I mentioned, we can actually operate as far away with these things, as far away as 6 to 8 inches on some of them, with fields of view that are quite large, up to 3.5 inches. This is the typical configuration for something like this, where we can get about 2 inches. 2.5 inches while operating further away, or as we get closer with the MiScope, what we'll see is our magnification increases. And here what we have are some different ink samples. And what we can do now, this is about 15-time magnification, is we can go ahead and look at the characteristics of those inks. So here we can see these are, for instance, ballpoint pen, and we can see kind of the way the ink sits on the fibers and the glossiness that we get from that. Here we have other more liquid writing instruments. This is a fountain pen. Here we have a roller ball, gel ink. Another kind of gel. So this gives us the opportunity to actually see the different characteristics. Now, as we go closer, here at 40 time magnification, we get an even more detailed view. And of course, with these, we can zoom in with this microscope all the way up to 180 times, which allows us to see the paper fiber itself. So we can see the fibers, we can see how the different inks interact with the fibers. So in this case, with the ballpoint, we can see how the ballpoint sits on the fibers, where there are some skips and some space in areas between the fibers that the ink doesn't penetrate into, and that some of these more liquid inks will actually penetrate all the way in and wet all the way down into the fiber area. The MiScope also allows us the ability to look at some of the finer details in the writing itself. So we can look at the shape of the letters formed by the stroke in the areas that strokes overlap. And again, we can move from a fine micro view, work our way back to a more macro view. And then, again, once we find an area of interest, we can zoom back again. Now this is done using the built-in lights on the MiScope, but we can also turn the lights that are built into the MiScope off and use other light sources. So one option that we have is to backlight. So here, using a little light pad, we can turn off the lights on the MiScope and now actually look through the page itself, which gives us a more detailed view of the inks and the paper fibers. So here we can see the actual fibers. And let's see, we have, here's our annotation tool. There we go. So for instance, here we can actually see the fibers. And you can see the ink actually being drawn along the fibers in certain areas. Let's see, clear that, clear all. Yeah. And the same kind of thing with a different kind of ink. Now another technique, in addition to working with backlights, we can also remove our backlight and we can use a side light or oblique lighting. Here what we're going to do is bring an area into focus. And now what we're going to do is turn the lights off and use a little side light, which can come in from the outside of the MiScope. And you'll see now with the side light, we get a much more detailed view of structure and shape. So for instance here, we can look at the paper fiber, and in the zoom view, we get a much more detailed view about how the ballpoint pen, in this case, is just sitting on the surface of those fibers. We can actually see the ink sitting up there, as opposed to perhaps here's fountain pen, where we can see how the ink has actually absorbed right into the paper. Another use for the MiScope, another sample that looks particularly nice, is pencil. So this is a pencil. We're actually operating at a slightly higher magnification now. Just we're seeing not as much of the view that the microscope sees. So we can actually zoom out to see the whole thing. But here, in this case, we can actually get the true one-time magnification, so the actual view that the camera is producing. It gives us a very detailed look, including the glow of the graphite from the pencil. We can see the individual particles. If you're looking for erased pencil to see if there are indications of something being erased, again, very easy to find those fine particles. And likewise, we can turn the lights off, go back to our oblique view, oblique lighting. You can see very nicely how the material sits on the paper fibers. And the remaining particles when pencil is erased. You can also see if there's something that's actually indented. Well, actually, here we'll zoom back a little bit. And again, use our side lighting technique here. Let me turn our regular lights back on. Now the next feature of the MiScope we should discuss, again, when it comes to imaging inks, is our multi-wavelength feature. So in this case, what we're going to do is to take advantage of the fact that our MiScope, in addition to white light, has a number of other wavelengths that can be very useful. Here's our lights on, our white lights on. Here we're using the light switch on the back. We can turn our lights off. And here we can now use our special wavelengths. And usually what I suggest is if we're going to be operating in the infrared, because there's not really color involved, we can turn down the saturation, that is essentially take what would be color out of the image. And now with this particular unit, now we are operating in here ultraviolet light, so we're looking for fluorescence. This has a short wavelength infrared and a longer wavelength infrared, and that'll help us in identifying inks that might appear similar just in one of these wavelengths. So let's, for instance, just scan through here. So these are ballpoint pen over here. And you see, for the most part, they're not dark. Some of them are a little bit darker than others, which indicates that they are different. Here we go to some of the more fluid inks. Again, this is a ballpoint pen, not sorry, ballpoint pen, a fountain pen. This is a, not a gel, this is some kind of roller ball. A gel and another kind of rollerball fluid ink. And now we can look at samples where there might be multiple inks that we would like to be able to distinguish. So for instance, here, I'll just bring these images down a little bit so that we can see everything in one. So here's a sample with what looks to be three identical inks, but here we can see by switching into the infrared that one of these inks is actually different. So again, white light, infrared. The same technique can be used for looking for, in this case, alterations. Was this document altered? In this case, it's a subtle difference and harder to identify using just infrared light. But what we will do is demonstrate another technique shortly that will help to identify whether or not there is an alteration here. And as I mentioned, also we can discuss or look at obliterations. That is, how can I determine if there is something beneath that at higher magnification? Might be able to make out something there, but it's possible in switching to a different wavelength that we could look through the obliteration and see something that's underneath. Now, it's important to note that this technique is not guaranteed. That is, we can look through this obliteration because, in this case, the ink that was doing the covering becomes transparent in infrared, and the ink that was written below is quite dark. But it's also possible that those two different inks that were used have very similar characteristics, in which case it wouldn't be possible to see through it. So this is a technique that can provide results, but there's no guarantee. And by the same token, because we find two inks that look similar in infrared and in white light, that does not mean that they are the same ink. They could be different inks with these same characteristics. On the other hand, if we find inks that are clearly different under infrared light, then we can conclude, of course, that those two are different. They was not written with the same ink. So let's next talk a little bit about infrared luminescence and how that as a technique can be used also for looking at and distinguishing between inks. Let's start by discussing a little bit about the difference between this process that's called IR luminescence and how it's different from what we would call regular IR imaging. So, or the kind of image you would get if you used just a MiScope with infrared light. So, let's talk about the two different kinds of processes here. So, if we have a MiScope with infrared light, the lights are built into the MiScope itself, and what happens is it actually produces infrared light that shines down on what we're looking at. So in this case, it would be an ink sample. And depending on the inks, the ink will either absorb or capture that infrared light, or it might reflect it, or it might just let it pass through and bounce right off the paper. So if part of the ink actually absorbs or collects up that light, then less of the light will then shine back. Whereas if a different part of the ink is basically transparent, the infrared goes right through and bounces off the paper, then a lot more of it will go back through. And so what will happen is the MiScope will detect all of this, and it will see that ink in different colors. So it would see the first part of it darker because that was the part that was absorbing the infrared light, and the second part lighter because it was letting the infrared light through. And so what we'd see on the screen is these different words in different shades of gray, like this. So turn that. So let's go to the next slide. Oop, went too far. So now let's look at this other process called IR luminescence. In this case, what's going on is we're not using the lights that are built into the MiScope, although we can, but we have another way of doing that, and we'll show what we call our filter wheel. But we're going to use a light source that's our excitation light source. That is, this is going to be the light source that is going to induce a chemical reaction of some kind in the ink. It's not really reaction, but a chemical response. So in this case, we're now shining typically UV or blue or sometimes a white light down. It's nicer. And that light is hitting the ink and now causing the ink to glow. So almost like one of those fluorescent toys that you got that you put up against the light, and when you turn the lights out, it glows green. This is going to operate on a similar principle. That is, this is going to glow based on the light that's hitting it. But in this case, it's going to glow all the way into the infrared in wavelengths that we can't see. So depending on how much glow is happening, we might get a lot of glow, or for a different part of the sample, we might get less glow. So we're going to have this glow coming back from the ink, and now we'd like to collect that into the MiScope. Now the problem is, in addition to that glow, we're also getting the light coming back into the MiScope. We're getting the background light in the room. We're getting this, what we call excitation light, this UV or blue light that we're using to create the glow in the ink. And all of that's going to make the glow in this ink hard to see. So what we're going to do is we're going to place a filter right underneath the MiScope. And what this filter is going to do is it's basically going to block everything except some of the light that's glowing from the ink. And that's the only light that will be allowed to go through and hit the MiScope. And so we can use one filter or maybe a group of different filters, which each one will allow a different range of wavelengths or different group of the light that glows to come through into the MiScope. And so in this case, with using this filter, all we would get would be the brighter glow from the first part of the writing, and so it would look lighter, and maybe a little bit of glow from the second part of the ink, and then also some glow from the paper that it's all written on. And so in our MiScope, we're going to get an image where the different inks will look, again, different brightnesses due to how much they are glowing. And so what we could say here is that we're using UV to create an infrared glow, and then we're using our filter to block everything else so that we can see that glow. So now let's actually take a MiScope and a filter wheel, and let's see how this all actually works. So we're back to our live image here again. And this time we've brought over our filter wheel. So this filter wheel has two different excitation light sources. So as I mentioned, we have a UV light source, we have a deep blue light source, and then we have 8 filters. The light switches here allow us to switch to the different light sources. And the filters we can flip through. And so what we're going to do is we're going to take our MiScope, and we can put this on top of our filter wheel. In this case, what we're going to do is we're going to turn our built-in lights off. And we're going to use the lights that are built into the filter wheel itself. And so what we're going to look at here is the sample that we looked at before. And here, before, when we looked at it in infrared light, we had a little bit of trouble trying to convincingly determine whether or not the 4 that was written there was written using a single ink or if it was altered by using a second ink. Here, what we're going to do now is start to flip through with our different filters. And in fact, what you can see here is as we cross over now into a different band, that we can see here we have almost no luminescence in the part of the 4. Sorry. All right, there we go. Let's get our tools. All right, so here we're getting glow in most of the ink, not this section. Now as we switch over, we can see that that effect becomes more pronounced. We can experiment with different wavelengths, but what we can see quite clearly in this case is that this date was altered by a different ink. And again, we can use this for other applications in comparison as well. The same in an obliterated sense. Oftentimes, the filter wheel, because of the difference in luminescence, can identify variations in inks that are much more difficult to determine with other tools by themselves. So that's an overview of using your MiScope to inspect and evaluate pen inks. Please stop by www.zarbeco.com to learn more about the different features of the MiScope and how it can be used in document examination. And also look for some of our other videos on other things that can be done, including looking at printed documents, differentiating between originals, laser, inkjet, differentiating between papers, and more. Thanks.